The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We will begin our free training for 30 minutes. With me is Kevin Reichel. Hey, Kevin, how are you?
Doing good. Kevin here with the better internet service than Mark has.
Yes, that's about what I was about to say. So I am having internet issues today, so if I pop out, Kevin is still in the driver's seat, or at least on the co-pilot seat, so he can easily take over. He doesn't have this part, but he basically does have this part, I guess, because this is one of the default parts that you can work on. So pretty sure he can just pick up where we left off. But let's see how far we get today with my crappy Canadian internet, and we'll see what happens. So yesterday we left off by doing the HSM to finish the entire part. So I'm just reviewing that here. You can see that by checking this box and having my little follower next to the HSM, we can see that we've pretty much gotten this far. I actually corrected it from yesterday. If anyone's seen the video from yesterday or remembers from yesterday, that 3D eye machining actually didn't go right to the bottom of the stock. So there was a little bit of a platform there. And that tends to happen when you leave a floor offset, even though there's no material there. So it's actually just choking up from the bottom of whatever the lower level was. So to correct that, I actually went back into the 3D eye machining and just told it in the delta box to go a little lower, meaning that in that 3D recognition toolpath, I told it to check further than the bottom of the stock. So that actually allowed it to recognize that there's more stock to remove. There is nothing to leave on the floor. So that eliminated all that material. So that's how we actually get that nice profile there. Okay, so automatically there's a question from Jake. Is there a good place to talk about smoothing? Would you mind take a look at that in function? Okay, so smoothing, if you guys remember from the HSM, and also HSS, and I think it pops up in a few other places, is smoothing is literally just the idea that if you look at that graphic in the bottom left corner, if I uncheck smoothing and turn smoothing back on, it actually generates some nice arc movements instead of those little line segments there. And when you check that box, you actually control it in this tab here. So I can tell it what radius to add whenever there's a little bit of a segment there. And then these are the tolerances to figure out how to best add that radius. Is that a fair description?
Yeah, definitely. And if you guys are getting any kind of jagged, maybe even geometry or jagged toolpath that's happening, that's where the smoothing was developed, exactly what Mark was saying. So it basically will do for you is turn those line segments into arc segments. And we've kind of seen with the older machines, they work better with arcs, where a lot of the newer machines with their the look ahead and features inside the new machines actually work better without with the line segment. So definitely that's something that you guys would have to play with on per machine basis. Like I said, if you got a newer machine, don't even have to worry about it. Older machine is where we kind of see that happen a little bit more. So.
You see this a lot when you're dealing with surfaces, or in like the case of an HSM, you're dealing with the surfaces of a solid, the faces of a solid. And that's usually because translations of certain formats might generate kind of weird surfaces. There's noise in the translation. So you'll get a lot of those kind of weird triangular surfaces or like straight lines kind of things. So it's like Kevin said, this is usually more for to smooth out those line segments, or smoothness of the toolpath, or just smoothness of the actual finish as well. We've had some customers that if they stick to the translated geometry and it looks exactly like it was translated, then you get this kind of like really old school graphic kind of pixelated kind of look to it. Whereas if you get this smoothing in here, it actually smooths it out and you actually get the proper smooth face to your mold or to the exterior of your part. So that's where we left off yesterday. We pretty much did all the walls on the floor, right? Now we've got the tapers here, and I guess we have to drill some of those holes as well. Now the holes most likely are done. If we take a look at that hole right there, that was considered a pocket by our 3D eye machining. And since I told it to go through the bottom of the stock, that's probably already done. The only thing that wouldn't have been done is whatever the tool that was used in 3D eye machining could not do, and that's going to be these holes here. So we'll drill those out and probably have to finish some of those holes as well, because I think we limited the travel of the HSM to just the bottom of the pocket. So we probably want to do those with a couple of profiles as well. But let's talk about HSS. So this one right here, this is a nice kind of just one single surface. We could do this with an HSM again. We could have probably included that strategy in one of our HSMs where we told it constant Z. We could have told it to do a little bit there. But since it's a single surface, it's a great candidate for HSS. So let me turn off the stock here. We'll go to Add Milling Operation, and we'll go HSS. HSS, being a surface-based toolpath, means that in my geometry, it's going to ask me for the surface, and since there's only one there, it's an easy one to use. You've got all the different options here, and since we're looking at this as a strategy thing, I would automatically think to use linear on this. But then I would notice that if I kind of angle this a little bit, it's not exactly always in a straight line. There's a little bit of a triangular portion right here. So if I use linear, I'm going to have to do some link between slices, maybe trim that up a little bit so that it actually does a nice toolpath, or I can just automatically go with morph between boundary curves, and then as it goes across, blend the toolpath. That way I don't have to think about link between slices. It won't raise the tool at all. It'll just kind of blend the toolpath and might even give me a better finish. So I'm thinking I would go with link between morph between boundary curves. What would you use, Kevin?
Yeah, when it was funny you were saying that the constant Z and stuff like that. I'm like, boy, I would have done morph between boundary curves, but nope, that's exactly what I would do.
Well, I mean, you could do constant Z on this as well, but the thing is, the step over you find in your toolpath parameters, this is no longer a step across the surface. Once you do constant Z, parallel cut constant Z, that's actually a step down in the Z direction. So it literally is doing a waterline cut. It takes that surface and slices it in the Z direction, and that always doesn't leave a good finish. That's more for purely vertical walls or maybe walls that are just off the vertical. But as soon as you get something that has this much of a taper, you're going to see a big fanning, a big distance between each slice there. But on this one, I definitely would do morph between boundary curves because I think it's just going to be a cleaner looking toolpath.
Yeah, and Brian is actually saying that right now, isn't morph between boundary curves almost always the first thing to try? And Brian, you and I think alike. Yes, that's always my first go-to. But between morph between boundary curves and parallel cuts, that's definitely a way to go.
Absolutely. I mean, like we talked about in our favorite toolpaths class, morph between boundary curves is the one I always go to as well. But the reason I bring it up is because if you're looking to do minimum clicks and minimum amount of geometry selection, if you take a look at parallel cuts linear, you choose just the surface, and then you would just choose your direction off of the x-axis. Whereas if we go to morph between boundary curves, it's a few extra bits that we have to do, but we have to add a start edge curve and an end edge curve. And depending on the geometry, this could be a bit of a pain. You might have to actually zoom in a lot to grab edges, or you might have to kind of angle it a certain way to go through transparent solids. Whatever the issue is, it's a little extra work. So and I brought this up once in a previous class, the programming time is also something to look at. So if there's less clicks you can do, then you can get your part done faster, and then you can get your code on the floor faster. But in terms of the quality of the part, the more work you put in on the programming side, the better the toolpath will be. And that's why I would go to morph between boundary curves as well. But it sounds like everybody's agreeing, but for different reasons, but that's good.
And plus, we're
okay.
like we said in the past, as machinists, I think we are all a little bit anal on how our toolpath looks and stuff like that. So you definitely got a lot more control when you have morph between boundary curves versus linear.
Yep, absolutely. All right, so I'm just going to grab this edge right here. And then we'll do this edge over here. And I'll just click next to go to the next one, and that's it. So not too many things to click on, but a little extra bits there. And we're going to do this as a finishing pass, so I don't have to do anything in the drive offset, but you can always use this to kind of rough out the surface first and then come in there with something else if that is somehow useful to you. If you find that HSS is a little easier to use than HSM, or even if you only have the 2.5D package and you don't have any of the 3D toolpaths, then this is a great way to do some 3D roughing in your 2.5D package. You can just add a surface offset, and then essentially whatever technologies, whatever toolpath parameters you plug in here, you can use this as a 3D roughing toolpath. Let's go to Tool, Select, and We've got a bowl mill on here, so let's just use that bowl mill. Okay. Levels, I'll leave it at automatic, but you do have the option here of setting it to a plane, but automatic is probably going to just generate maybe the same thing. Toolpath parameters, let's put this at 20 thou. We'll leave a good finish, and I'll leave it at zigzag so we can do a nice clean looking toolpath. But for the best finish, obviously we'll leave it at, we would put it at one way, and then we'd have to deal with the retracts just to get it to go in that one direction. Link, I usually say to leave this as is so we can see where the linkages are happening, and then we can address them a little better. As soon as you start changing this and then you have to troubleshoot it later, you're not sure what you're changing back and forth or what you're addressing. So I usually like to leave this one as is and then come back later after generating it and then see where I need to fix it. But I can probably already guess that I'm going to have to do some link between slices and change this from clearance area to probably follow surfaces or something like that. But I'd like to leave that as is, and then we'll check it out. Gouge check is the idea that in your HSS toolpath, it only sees what you told it. So it only knows about those surfaces that we told it in the geometry section. So if there's any nearby walls or floors that this thing's going to collide with, I could turn on my gouge check and then make sure to avoid those. In our case, this thing is the taper on the top of a wall. Chances are it's not going to collide with anything, so I'm just going to leave it as is. I don't have to do anything there. And I mentioned a second ago that you could use this as a roughing toolpath if you didn't have anything else to work with. If you have 3D eye machining or HSR, or even if you have the 3D milling toolpath, any of those three-dimensional toolpaths, you're not likely to use this stuff over here. But if you had only HSS, you had full HSS, then you have the ability to do very similar kinds of toolpaths with your multipasses, depth cuts, and even stock definition. But in this case, we're just finishing that, so we're not even going to bother with any of that. We can do a save and calculate. And from the looks of it, the movement was so small that it ended up being just a direct move, but for whatever reason, it thought to come from that direction, and that is probably because it's set to Mach 2. So let's put this back on Mach 1. And we'll just translate that back there. So from the red ball, you see the rapid movement down. And this is actually going back to something we talked about probably last week, some of the color coding of our toolpaths. So from that red ball, the red movement is our rapid down to this clearance plane here. It feeds from here. And the yellow is actually the toolpath itself, the material engaging toolpath. Going back and forth, we can see that it's actually feeding off the part to go back and forth between the slices. So I didn't actually have to go to my, my link section, and I got a nice toolpath to clean that face. So I want to do the exact same thing on the other face. Well, I could maybe go ahead and use some transforms or anything like that. Or, I mean, this is very simple to come up with. I'll just do a save and copy. And then we'll just reselect new geometry. And this could be another reason why you might want to try using just linear, because if I did a save and copy and just reselected the one surface, I could just calculate right now. I'd be done because the direction would probably be the same. But since we're doing morph between boundary curves, we'll just do it the exact same way. So I'll just grab that edge right there. In this case, this one has a little bit of an extra curve, so we have to do it, choose those two edges there. And then on the inside, grab that one there. Okay. Now I'm hitting the next button, but I probably could have turned on my tangent propagation and then got it to choose all that for me as well. So there's lots of different ways to choose your chain geometry. But there you go. So those two faces are done. And I'm looking at the two of them, and this one actually starts at the top and goes down. This one looks like it starts there. So if for whatever reason I don't like that, I can always go back to the HSS. And in toolpath parameters, under sorting, I can flip the step over.
Yeah, some reason when you did the when you switched from Mach 2 to Mach 1, it lost your geometry lines, so just have to grab those.
Yeah, interesting, but it's still calculated. Oh, well.
Yeah.
Okay. Well, the reason is because we changed Mach, and usually when you choose chain geometry, it's really reliant on the Mach that you're in. So when you are doing, let's say, a pocket on one Mach position and go to the other one, those geometries only exist in those Mach positions. So by changing it, I literally lost the geometry. Now, for whatever reason, it's still calculated, so that's an interesting thing. But Let's see what happens when we recalculate this. Okay, so it still starts from the bottom, so we'll go toolpath parameters, and we'll flip the step over back to the way it was. No, okay. Yeah, well, for whatever reason, I guess it wants to go that way. So those two are done. Let's hide those. And let's drill some holes. Those holes, I guess they're all the same size. What size are they? So I just click on the edge there. Bottom right corner shows me that those are 3/8 holes. Perfect. So we'll add a 3/8 drill. We can drill all those holes. And this should give us the opportunity to show one of the new functions inside of either 2019 or 2020. I don't remember when they introduced this, but Kevin probably knows what I'm about to talk about. The ability to just choose these holes here and these holes here, but it's only really going to retract to a clearance area, probably just to go around this wall, and then these other ones, it'll stay close down to the level there. So let's see what happens. So we'll grab this. Right, okay. Are we in the wrong coordinate system once again? No, we are in the right coordinate system.
You got it. I think you accidentally got stock.
Possibly. Here, let's angle this. There we go. And we'll choose this face as well. Now, when you choose the face inside a drilling operation, it grabs all the complete circles in that face. And in this case, I chose that one there, and it actually chose the center circle there. And that's not what I'm looking for. Obviously, I could easily just go down here and say, okay, so I don't want 0, 0. I could just grab that one and delete it from my list. Otherwise, I could have actually added a filter, so by radius. And if you guys haven't seen this, we'll do it again. So we'll go new. And I'll click on the filter by radius. So not all circles, but just by radius. I'll click on the button that says by radius and grab an example of the radius that I'd like to machine. So this one right here records that as a 3/16 radius. And now when I click on a face, it grabs those two holes. Yes, because those are the right holes. But let's see if we grab this face here. It only grabs the holes with that radius. It does not grab the one in the center. So if you have an entire face with different sizes of holes and you want to filter just specific holes, this is a way to do it. You can use this by radius, and it only selects the holes of that size.
Or if you guys wanted to, you could actually expand out your feature tree and just click it right off of the hole wizard that's in the feature tree for the design.
Yeah, that too. I guess these holes right here, these ended up being, yeah, look, right there. So, and that, I guess we could talk about hole wizard too. There's not even really a point of me having to do a drilling toolpath if there's a hole wizard here. But just to show that new functionality, I want to go over across this wall here. So let's go green check mark.
We'll show you guys 2 different ways to do it.
If the internet stays.
Yeah.
Okay, so let's just do a quick selection of our drill. And let's go new. And rather than importing it, I'm just going to grab the default size and we'll just make this 3/8. Like so. Levels. So we will do my updated stock. So it'll look at my updated stock, and depth, well, we'll just tell it to go to the bottom of the part. Possibly right there. And then we'll say full diameter as well. So we'll put dip the tip of the drill past that point, and also maybe just a little bit extra, just so we can get rid of some burrs and stuff. So there we go. And then technology, we'll do that as just the G81. Save and calculate.
And the reason that you guys are seeing the updated stock pop up now is because Mark told it to look at the updated stock to eliminate those retracts going all the way up. So kind of like what Mark was getting at before, is it will only have to retract up high to skip from the inner or the outer web into that inner web area.
Exactly, and it does increase the calculation time a little bit because it has to look at the updated stock, but it is intuitive. It'll know that it doesn't have to retract all the way to the clearance area just to do these holes in the center here. It's like Kevin said, we'll just go from the inner web to the outer web, or the outer web into the inner web. Okay.
And now we can put our safety levels down. Yep.
shortest distance,
Yep.
right? Okay. So that is how it used to be. Now we can do a save and calculate. You can see that it only jumped to the clearance area to go over that wall, but otherwise it's going right from there to there, and on the inside, from there to there. Now I don't know why it has those green circles, but that's still basically the same thing there. It's just going to go from each hole in the shortest distance. Now that's if we did it with just the standard drilling toolpath. I'm going to suppress that guy. And if you guys haven't seen Hole Wizard before,
Better be sitting down for this one.
we'll go to Add Hole Wizard. So it's outside of the usual toolpath tree. And what Hole Wizard does is I can just grab that surface, I think. No, I got to grab the
hole. Yep.
On the hole there, and I should just grab everything from that same Hole Wizard pattern.
So basically all Mark has to do is just tell it what he wants to drill, and it's going to look through the entire part for all the holes that are that exact same size. Doesn't matter on if it is on different levels, different depths, it's all going to pick that up all automatically for you guys.
Yep. And if anyone is familiar with the Hole Wizard, but from a previous version of SolidCAM, you'll notice I didn't have to tell it what type of hole I'd like to do. I just clicked on the hole, and now it'll recognize that as well. So it used to have to say, okay, I'm going to look for tapped holes, and then it'll recognize the tapped hole and the type of tapped hole. But in this case, I just clicked on the hole, and it found out that this is just a standard simple hole. Now with the Hole Wizard, though, it actually adds more than just that one toolpath. It actually added a spot and then the drill. And the depth looks like it's a little more because whoever modeled this probably told it to go a little deeper than that. But that is what the Hole Wizard is reading from SolidWorks. It's understanding those levels from SolidWorks. Okay, so let's see some questions here. So does the start point in HSS change the cut direction? No, not the start point. I think is usually just to literally start the toolpath, right, Kevin?
Yeah, and well, it definitely depends on the surface. So I mean, we can try it here, and usually the way everything starts is all dependent off that physical surface itself and how that surface was created, because HSS is looking at the surface NURB, but sometimes that start position will change that area, and sometimes what it will do is it will start over there as a start point, but it won't start cutting because it will retract down. But we can on this particular one, it may change it up, like what I think Scott's talking about there. Did we lose Mark as with internet? I think we lost Mark. So, and let me see if I can. I suppose I can't control his computer because he completely lost internet. So, yeah, what Scott's talking about is in the toolpath parameters, we can do the flip step over, and then there also is a start point. And like I said, it depends on the operation and the surface itself. But in this particular case, Mark could switch the start point over to start from that one side to the top side and switch it back over. Oh, looks like we got Mark back. Maybe. Let me see if I can control his computer. And
yeah, I'm back. I'm back.
There he is. Okay.
So, like I said, something was going to happen to my internet, and it just happened. So while I was away, I actually added a start point. So I just kind of freehanded it. I chose it up there, and it does change the direction a little bit. You can see I told it to basically start closer to the top there, and that's what happened. But I missed completely what you were saying, Kevin.
That's exactly
you don't
what
have
I was
to
going
repeat it
for.
because everybody else knows.
So hopefully, does that make sense, Scott, for you? And I think okay, perfect. And then Brian was looking to solid verify, I think the drilling.
The original
Yep.
drilling,
Yep.
yeah. So I'm gonna unsuppress that. And it thinks there's a change because I updated that HSS, so we're just gonna run through that again. Anytime you have any kind of stock recognition, I mean, this is not really stock recognition, but it's looking at the updated stock. It also wanted to be updated because of whatever change I made to the stock. So just as a review, this is the one that is doing that shortest distance. Let's do a solid verify on that.
And this new feature that they came out with 2020, keeping that tool down, going over over the webs and stuff like that, you know, is really going to come benefit if you guys are doing a lot of holes with a lot of ribs. Is where that really comes into factor. Because you think about it, doing a G00 up to 1 inch versus keeping that tool down. I mean, we're talking about, you know, very minute stuff that's going on there. But, you know, if you guys are having a lot of holes over, you know, a lot of parts, that time definitely does add up for us.
Yeah. I also think about it like it's another level of associativity. So if you're intending to drill that hole, but maybe at that point you haven't done the pocket yet, or you make a change or revision change, and then that hole is no longer there, or not that hole, but the pocket's no longer there, but the hole is, or there's something about the part that changes. This is recognizing that stock. So it knows to change the levels of that drilling tool path based off the part. So not so much always just the fact that you're going over those webs, although this is what it's pretty much developed for. But for me, I'm always looking at the overall picture of the associativity, and this for sure, it addresses that. If that feature now disappears, but that hole is still there, this will now update the toolpath to start on the new level of that drilled pocket.
And maybe, Mark, I think what Brian was looking for on that one, switch your settings over to show every single step.
What do you mean, like
yep.
up here?
Yep. General.
Yeah, the general. Yeah, misclick. So instead of.
Yep, just put the one. So instead of what we were doing before, showing you guys every 15 steps, now if Mark does the playthrough, it will show every single step.
So it actually went and did this hole, went over there, and then came back. But that's basically almost what we wanted to show anyway. It does that hole, jumps over, jumps back, and then when it's in here, it never actually leaves this pocket.
And if we wanted to switch up that order, so if we wanted to do those 2 holes on the outside first and then go inside, we could do that in the the order itself under the technology section. But
yeah, so default is the order they were selected in. Shortest distance will recalculate it so that it'll actually do the holes closest to each other. Although these ones, they're probably not that different, but advanced would also allow us to change the order as well. So in this case, we could probably tell it to do something a little more circular, although it's already circular. But if you literally wanted to go in there and change the order, so the default order, that's just under here. You just go into edit, and then down in the list, let's see, we have holes 1, 2, 3, and we should probably make hole number 3. So I'll just grab that. Actually, grab number 2 and move it down. And now you can see that the order is now like that. So in check mark, same calculate, and now it does that hole, then jumps over, and then does the inner circle.
And that's why they switched up the so you can see the green lines in there now, to make it a little bit easier for you guys to kind of see what's going on. So now that we don't have those retracts anymore, what they do is they keep those green lines in there so it can kind of show you the pattern that it's going.
Okay, so any questions on anything we've covered today?
Holy cow, that went by really quick. I didn't realize
that went by really quick, yes. And even with the internet drop, we still got to cover it, so that's good. Or at least the internet on my side. If you have any questions, while I can still receive email, Kevin will put my email in the chat section. And then you can always email me with your questions, your topics, whatever you want to have covered in the class. We'll continue with this part. We'll do side 2 on Monday. But if you have any questions in the meantime, obviously we will address those in the next coming classes, or we can even, if they're not pressing and you want to get this thing finished, we can save those questions for the end. We've got lots of time. We're doing this until the end of June, so we can do more parts if you have parts you'd like to see, or more topics if you've got more topics you'd like covered. The finder's fee is available if you know anybody that can benefit from SolidCAM. You get that $100 gift card for just getting them into a demo. You get 20% of the sale, the final sale, if they go into sale. So if you know anybody, let us know. Just put them in contact with us or get us in contact with them, and that can get the ball rolling. If you're interested for the details on that, you can always contact your local salesperson. For today, we'll leave it here, and stay safe. Keep your family safe. We'll talk to you on Monday.
All right, guys, have a great weekend.